This meeting is being recorded.
Hi, welcome to the Open Security Summit session on September 2022. And we're going to have a really interesting panel around blockchain and its security. And we're kind of going to probably stay a little bit away from the whole crypto side of blockchain, because I think there's a huge amount of other things around it. So yeah, and then as I help to run the Open Security Summit, so maybe we can go to Zenobia, and then tonight, James and Anish, just give a quick intro and your interest in blockchain.
Sure, absolutely. Thank you so much. So this topic, as Chenxi and others know, is near and dear to my heart. My background, I started off in infrastructure, working for Mark Andreessen and Ben Horowitz at what was LoudCloud and became Opsware. I then took sort of a sharp left turn and worked on the sell side for a number of years as an analyst covering internet security and infrastructure. That market has obviously grown significantly as the web has grown. In 2015, I was introduced to two entrepreneurs who came from the identity side at Ping Identity and were working on a new, at the time, private blockchain, which then turned into, once it was proven out, turned into the layer 1 network, today known as Hedera. So my interest is very much in real world, highly scalable applications for distributed ledger technology. And, thinking about, we are building these applications sort of in the public eye, right? And you are having to manage your infrastructure in the public eye where everyone can see that. And in some ways there are great benefits to that. In other ways, there are security concerns that are now having to be taken on by the applications themselves. So if you are building something like a network for cross-border payments, if you are building supply chain, applications that are thinking about pharmaceutical supply chains, these are mission critical applications, and you are going to have to think about every layer of technology that you are using and applying, and how to secure those different layers.
Cool. Chenxi?
Yeah. Okay. Oh, good morning. It's really early here on the West Coast. So I'm Chenxi Wang. I am the general partner and founder of Rain Capital. We are a Silicon Valley-based cyber-focused venture fund. Before I became an investor, I was a technologist by training. I have an academic research background in applied crypto and distributed system. And then I went on to industry research. I was 6 years, I was in Forrester Research covering security markets. So I worked a lot with different security technologies back then. Then my background, my career journey took me a different turn. I became operators at different companies, mostly cyber. Most recently, I invested in a blockchain company called Oasis Labs. Some of you may know, and it became Oasis Foundation. The company is doing a lot of interesting things in distributed computing and multi-party computing, multi-party computation, which is very interesting to security technology as well as to blockchain platforms. So my interest in blockchain is twofold. One is, what can blockchain do to help us with distributed computing and security promises that wasn't possible before, and also what do we do to secure blockchain? So I'm hoping to dig into both of these aspects today.
James, throwing you at the deep end.
James or Jim, depends on how much trouble I'm in. So I'm a head of security for companies in regulated industries. And my interest in this, so I had a little bit of involvement with a product called Levian, which was a coin that was used to power a browser-based VPN. So the idea is that the browser's the miner, you mine the coins, or you pay to access the VPN. Rubbish, but it was a very good very good learning experience. But I have an interest in two areas of where I'd like to, with blockchain. I like to, if I get angry with a process that's happened in real life, and I just want to put that on the blockchain. If anyone's bought a house in the last 10 years, then you'll sympathize. But I also think there's some really cool potential for data loss prevention, maybe putting documents on the blockchain and managing those through smart contract features, which would be really cool. And that's me.
So I guess it's me then. Can everybody hear me okay?
Yep, all good.
Okay. So yeah, I'm a slight oddball. I have a degree in medicine, 2 degrees in math. I went to grad school in Royal Holloway. That's how I know Dinis. So I've done lots of things, everything from bioinformatics to cloud, a lot of the security stuff, indigenous standards. I was involved in writing it up. A bit in big data and machine learning and all the random rubbish. Gave my first strata talk in 2012. Then I became an advisor to Ripple in 2013. I ran into the Ethereum folks. So worked with the Swarm team. So Ethereum Swarm Orange Paper. I'm one of the reviewers. So what that is worth. I've been involved in design of half a dozen layer ones and probably like 20 odd dApps. Now I am the founder, CTO, and chief scientist for a protocol called Panda Protocol. Very much a ZK privacy kind of thing. So mostly interested in identity, privacy, all the things that happens across the sector, like in DeFi, VIDs, and everything else. Hope that helps.
Cool. So I actually, just maybe as a context, so I actually have 2 roles. I'm the chief scientist of Glasswall, which is a security company in the UK that builds technology on CDR, which is content disarm and reconstruction. So we make files safe. And I'm also, my main role is on Holland & Barrett, which is a UK retailer, which has 1,500 stores, all about wellness, and is about to embark in a massive wellness transformation program where it's all about health data and managing data. So there I'm the CISO. So in a way, I'm very, very interested about using blockchain to protect files and the chain of custody and how we can map that bit. But also now that I'm getting also into medical data, I think there's a huge amount of areas that we can use blockchain to not just protect, but to verify, especially because integrity in the wellness world is absolutely critical. In fact, more than availability, sometimes even confidentiality. So it's kind of an interesting part. So I guess, Zenobia, you talk about the ledgers, right? You talk about using blockchain for the ledgers and good use cases. So where are the challenges that you see today, and where are the areas that you think there's a lot of great opportunity? And we'll just take it from there.
So I think that you are essentially building your applications on top of a stack where, you used to control a lot of that infrastructure, right? Especially when it was in your data centers, when it was all managed by you knew exactly what was going on. Yes, you always have vulnerabilities that you have to patch, but you were controlling those things. As you move to the cloud, you said, okay, great. Well, I'm going to put my trust in someone like an Amazon, and they're going to have a robust security model that I can review, and I can decide what additional security controls to put on top of that. When you are using public ledgers, you are essentially saying, okay, I'm going to trust not only the code, which I can see, but also the set of, node operators and validators. There's a lot of discussion around, are these systems actually distributed, and how distributed are they, or, are they actually, is there a consolidation of power, right? So I think before China closed down mining, there was a huge percentage of Bitcoin mining that happened in China. I think, post Ethereum merge, there's some conversations and questions about how consolidated is that, sort of hashing power, how consolidated is that? And do you know who's actually in charge of that? So just starting at that very very base layer, and having to think about those concerns, and then thinking about all of the different, parts of the puzzle that you are putting together that, require your application to work. So, we're still so early on, right? If I tried to tell somebody, well, great, you can go use this application, but you also have to go download this wallet that's from another third party, and then integrate that into your browser. And then you have to also go and trust this other site, this exchange. You're asking people to have a lot of trust in a lot of disparate systems. And then you are trying to build your application on top of that, because they each require those pieces of functionality. And so really trying to think about, do I know and do I trust the security of every piece of functionality that I am putting into my stack? And I think there's a lot of things that we are doing, in terms of formal methods and proofs, and being able to share, the sort of the security of some of those pieces of the puzzle, but there's a long way to go there.
Is it okay if I say
Yeah,
something
absolutely.
slightly different? Yeah, so a couple of quick things. So, the challenge of actually having OFAC and, kind of permissioning in that sense is a big one. So it could literally result in having two sets of results for the same consensus. So, imagine the switch from proof of work to proof of stake. I think you were kind of alluding to that. So effectively what that means is, because a lot of the stakers are in the US, the folks that were in China, they moved around, it was still decentralized, but the control of the US was much less. Now, if you look at proof of stake, a lot of them, Coinbase is kind of not really giving us a clear answer to how much they have. Like, everybody expects them to be having a significant stake, right? There are other significant staking providers that are based on that. And there's a very important thing that you kind of alluded to, but not normally recognized by everybody in this ecosystem. Web3 only exists on top of Web2. You can't run a Web3 protocol without having a Web2. And there are multiple implications to that, not just the fact that you require it, but the services that you actually have to use. So if you think about Ethereum uses Infura as a service provider. Infura is sat on top of AWS. So, there are, two things that are going there at the same time. One way is the trust that's going that way. The other way is this regulation flowing that way around. So, if you think about it from Ethereum, so an OFAC actually has this SDN where you sanction a bunch of things. What that implies is anybody, anywhere touching this is in trouble. Ethereum having a bunch of addresses is going to be a problem for Infura. When that becomes a problem for Infura, it becomes a problem for AWS, right? And AWS then goes, I'm going to kick you out from AWS if you don't do this. Infura then goes, oh, Ethereum nodes, guys, I'm going to kick you out because if you don't do this. This is, enforcement this way, trust this way. What I mean by this is like, trust in the sense like, Infura guys have to trust AWS that they're going to have all the security constraints that you have. And then Ethereum has to trust Infura that they're actually going to do what they're supposed to do. The funniest of the things I should point out is the fact that trust for everything that we have in the blockchain sense exists this way, but it doesn't propagate the opposite direction, which is kind of an irony. I thought I should point it out.
Well, that's going to be my question. Like, how do you use blockchain to validate and to verify those security properties that you said we need to go all the way down, right?
It's very, very difficult, right? There is no tie-in in that sense. So there is no cryptographic mechanism to tie in everything backwards. You can tie it forwards, but not backwards. And this is one of the things that everybody seems to forget. And whenever you have all these arguments, everybody makes an argument about, not downward. Mm-hmm. So think of it like in 802.1x, right? 802.1x sits over there, but gives you authentication below, right? But no such mechanism exists for a blockchain to actually, go all the way down to everything. I mean, there's a possibility. I mean, I know one of our panelists actually has some closer ties with Oasis Labs. I used to know the head of products for them, and I know they were looking at some of the things, and I used to help him a bit. The previous product manager, you can share your insight. Yes.
Yeah, I was going to jump in. I said, I think everything you said is correct, but there are protocols out there or implementations rather out there that ties itself to TPM or TPM equivalent, right? And you could trace your trust all the way to hardware root of trust, but that's not all. That's not.
Yeah, it's a very slippery slope. Yeah, it's a very slippery slope because I mean, I published my first paper on TPMs in 2015 years ago, right? So I had this conversation yesterday with somebody who was an investor. He is an investor in a TPM company based out of Bay Area. He's one of Dan Bunny's students. He has a startup now. I mean, like the person who actually runs the company. And I was explaining this challenge. The challenge of actually having something like SGX is if there's a bug, which has been a consistent feature for SGX, look last 4 years and see the number of bugs that have come out. You can't fix the bug in software. B, you have to trust that the implementation, the formal implementation that Intel gives, and the implementation that actually happens in the fab, right? Nobody has verification of fab.
But can we take the problem separately? If there's a bug in a particular implementation, there's a bug in that implementation that doesn't in itself invalidate the whole concept of TPM, right? So those are two different things. I think the concept.
I would agree to disagree, because like as somebody who worked on it, I can tell you, if the security model is broken, if the assumptions are that if the security model is broken, the security model is broken, irrespective of how it is. So as an academic break, right?
No, I vehemently disagree. Okay, so I work.
You should. You're an investor. I'm not.
SGX really well. SGX has its problems, and so are a lot of other problems, a lot of other implementations of TPM-like systems. But if you take it apart, I mean, Dinis would agree with me. Anytime you write software, right, there is a problem that software has a bug. Now, that doesn't mean that software itself is not worth writing. Those are two different things. Now, there will not.
I think the security model is different. The security model of SGX is based on a very core thing, which is the implementation. Security model of a software implementation is a slightly different construct. A software I could just update by
Look, SGX itself is one instantiation of TPM. It's not the whole.
Yes,
TPM.
I know. Yeah,
so
no, it's not. Yeah, I agree.
It doesn't invalidate TPM. Well, this is kind of fun. We start with an argument in the beginning of the panel. I love it.
But isn't the whole point of, in a way, blockchain to allow distributed verification, right? So
yes.
So look, correct me if I'm
wrong. This is exactly the other point.
Okay, correct me if I'm wrong on this, but I kind of I sort of see blockchain as a chain link of verifications, right?
Yes.
Maybe simplify, but I remember reading a lot about it, saying, yeah, this makes a lot of sense because you need to verify the chain of authority. Who the hell is touching this, right? Or who is making assumptions? Who is making decisions? What does one
typically a Merkle tree? Yeah,
but ultimately,
maybe. Yeah.
But there are hashes,
kind
right? So my point here is that they are fundamentally hashes, right? Stronger cryptographic hashes of this, right? Now, it's almost like what the hashes means is what we agree, almost the community agree, right? So let's say, taking Zenobia example, or your thing of AWS. So if we need to kind of verify that AWS is secure or is secure to a certain degree to a particular set of standard, whatever, right?
Yeah.
And we're putting things on top, and then we're putting things on top, putting things on top.
Yeah.
It's almost like we need to agree on how we're going to measure the first set of security and what is the hash that looks like to make sure that I can achieve the same results somewhere else, right? And then you build on top. Now, if there's a bug or a problem in some of those, actually, the more variety of implementations you have, actually the more confidence you have that the bugs are actually not that critical. Like, it's unlikely that 5 different teams who wrote 5 different implementations will have the same bug, right? That causes the chain to be broken, right? And a lot of these things is, sometimes I feel that we are a bit too purist on this. So more and more, I kind of use security as a chain of side effects. So I'm like, you can have a crazy vulnerability, but what's the side effect? And if the vulnerability is crazy, there will be side effects. There will be exploitations. So if you're telling me that I have a blockchain and one of the steps is maybe not as secure as everything else, but actually, is it realistically to mount an exploit using that particular part of the blockchain that happens to be vulnerable in a way that nobody else detects it? Okay, maybe there is one scenario, but in the real world, 99.9% of the problems or the attacks of the stuff won't fall into that category, right? So what I really like about the blockchain is the ability to create verifiable ways. It's almost like a scientific community to say, I made this experiment, here's how I arrive at the experiment, here's the formula, the stuff that goes on, and every one of those has a little signature that when I want to replicate that, I can actually verify it. I don't know, am I being too simplistic?
Yeah, I mean,
blockchain?
I might add a couple of caveats to it. So firstly, what you said is just the context of Merkle tree. But the thing with EVMs, and this is generally how these problems happen, right? Like, EVMs have this construct of security margin, or the cryptoeconomic security margin. And this generally gets broken, and this is pretty much very hard to verify. You make a bunch of assumptions, and the adversarial games are completely outside of the Merkle tree. You don't capture any of the constraints that you have on the Merkle tree. So in the protocol design, you make a bunch of assumptions, and that form your cryptoeconomic security margin. And when that is broken, I mean, the chances of that getting broken every now and then is low, but look at all the bugs that happen, right? Very simple ones and the bridge ones, right? Mm-hmm. The trees are all perfect. The blockchain security is not broken. I can give you examples. Again, curve, right? Same thing happened. Protocol-wise, no real security bug. It's a cryptoeconomic bug. The economic implementation of the protocol is not secure. So, it has layers and layers and layers of complexity. If you don't have an EVM and you don't have any of these things, perfectly fine. If you have an EVM and you use any of these things, then it's a small problem.
Yeah.
So can we maybe take this in a different direction, or maybe rise up a level a bit? Because I agree that if the assumptions are unfound, then of course the security model that followed the assumptions would not be sound. And by the same token, if the implementation has severe vulnerabilities in it, then the software instantiation followed by that would not be secure. So, but those are problems that we've dealt with for eons, right? Not just for the blockchain world. But if we take it a level up, talking about what specifically about blockchain that has its unique security problems, or it has unique security properties that let us do computing differently, I think to me that's a more interesting conversation.
Yeah. I agree, right?
That is exactly what I said. I mean, I don't know how you see the difference. So I described exactly that. I said cryptoeconomic security margin of a protocol is a construct in a blockchain, especially if you have an EVM. That's what I said. So we don't have normally, we do have consensus, okay? But the consensus is normally at the level where you don't really vary the hardness of consensus in normal protocols on a dynamic set.
Okay,
or you do anything beyond that.
Let's take a practical example, right? And I think you said that a lot of the stuff that exists today sits on top of AWS, right? So how can we apply blockchain technology to verify an AWS environment, for example, or an environment that there's some compute happening and I want to have a degree of confidence of its security because I'm building other things on top, which I'm going to connect to that blockchain. But what does that first part of it look like?
I'll let somebody else go first, and then I'll give a go. But I have a slightly different view because like it's some things are pretty hard. Okay, I'll go back to what you proposed before, a heterogeneous environment, right? If I actually had a set of compute that I want to do, if I have multiple environments, and if I could do a probabilistic, computation in that sense and compare them, then I have a high level of assurance. I don't have a verifiable mechanism at this moment in time. I have a probabilistic mechanism, right?
So,
Or I don't have a deterministic mechanism to say something is valid.
I think fundamentally it comes down to, if we're going to argue about whether the root of trust is sound, is valid, and then it's going to be it's going to degenerate the conversation, because, well, what are we going to do in the end? We're going to say, oh, the only way we can have it secure is we'll have a co-CPU that verifies every single transaction. I mean, that's just not feasible, right? So I really love to talk about, like Zenobia and I talk about how blockchain can enable things that were not possible before, and what's the type of application we can build on top that is it gives us trust that's more easily verifiable than what it was before. Those to me are more interesting.
Cool. So what? Give me a scenario. Give us an example of something today that you feel that could be verified with the blockchain that is not today.
So I would turn this question to Zenobia, because she has given a lot of talks on this, and I love her view.
Yeah, so I think, I one example I always love is I live here in Atlanta. Down the street from us are our good friends at Equifax, who managed to lose, I don't know, out of the 5 of us on this call today, how many of us, got credit monitoring notes and notes from the IRS saying, sorry, Equifax has lost literally all of your data, right? The fact that industry exists and gets to control our data and gets to then sell it back to us and to other people, to me is just it's a ridiculous premise, right? So if you are thinking about anything where there is data that somebody else owns about you and simply functions as a broker or a middleman, that to me is an area where you say, great, I would rather have distributed trust with all of its flaws that we are going to think about and we are going to try to fix, because we are coming into Web3 with more cynical eyes, right? We built the web not with security first, but hopefully we do a better job in this version of the web. But anywhere where one single entity today holds a lot of my data is an area where I get really uncomfortable. And I say, I would rather trust, I would rather have cryptographic distributed trust, computational trust, than trust in, a bunch of people who are, who, yes, humans are fallible, right? They're going to make these mistakes, but also we are putting all this data in one singular place, which is, which we don't have any control of, whether we have that data there, whether it's deleted. We have no option to, control who gets access to it. Those are the ones where, if you think about what people own about you, anything that puts, not a great feeling in the pit of your stomach is probably something where we can leverage more of that distributed trust.
That's interesting.
Can I be cynical? Sorry, go ahead. You go first.
I'll say, and kind of alluded back to your original case scenario there, Dinis, as well. I can see what I feel really uneasy during, and this is like a real world, far away from the science, right? This is me farting around during the day. I get really uneasy during due diligence when I'm supplying potentially very sensitive stuff about security to people who I don't know how well their security is, and then I have to ask them for their stuff, and then we just both end up, not reading the documents and holding them. And I think that it would be, I'd love to see, I'd love to see something where I could put my risk level, and my risk level can be put on the blockchain, and then I could just kind of give that to somebody, and then those risk levels match, and we say, okay, we're compatible. This is great. Or because, and I'm trying to think of like real world, and that distribution, the trust of the network is important, right? So right now, like an ISO 27001 certificate, the only thing that gives that its weight is the the country, in the UK it's UCAS, and then the IEC, it's that IEC badge. So there would have to, it's that network, it's that who do we trust to process all of that. And but that's a really cool scenario where I think it's screaming insecurity for everyone's just showing everyone else their dirty laundry, and it's dangerous that it's just floating around out there.
Yeah, I think about a data room, right? Anytime somebody is doing a deal and it's like, oh, sure, put all of your data from both sides into this one, trusted data room.
Yeah.
Trusted data.
I was about to say, so go ahead. Yeah, I was about to say, like, a cryptographic mechanism already exists. I know I put my hand up. I've been involved in at least half a dozen layer ones. So me being cynical is my cynicism. So it's how I operate. So, as it is, I would say MPCs and FHEs would allow us to do what you just said without having a blockchain.
Mm.
And, some construction blockchains actually have MPCs in the set. So, for example, zero knowledge. So, we can actually have an MPC set, n out of k, and then you could reconstitute, and they could do compute. If it's FHE, you can do the whole machine learning encrypted. So it is very possible. The construct in which we can actually use blockchains would be, we can have an oracle mechanism to actually measure something, and then release keys or allow access. But again, we would still require some cryptographic mechanisms outside of blockchain as we stand. That's what I.
But the thing I think is not. Oh, sorry,
sorry, I would agree, but I think MPC is a particular instantiation, right? So you and I can do an MPC protocol, and we can do secure exchange of information, but doesn't mean we can do the same thing with Zenobia, with James. We have to do another MPC protocol. So blockchain is a platform that allows many different applications built on top. If we trust the infrastructure, which as our discussions have alluded to, it's a big if, then it's a platform for us to do computing in a decentralized trust way, as opposed to every one of us have to do our own MPC. So I think that's one difference. Another difference is that I think the one thing we didn't touch on is the blocks, if they're written, they're there, right? They're tamper-proof if we trust the system. And having tamper-proof account of transactions is a really interesting property that multiple parties can verify, and it's there, and it's not going to be destroyed. So that's one thing I think.
I'm sorry to. Yeah,
let me finish.
Probably point out. Yeah.
No. Let me finish. Okay, it's not. I don't think it's polite to jump in somebody's argument when they're not finished. Please. So. And that's a property, that tamper-proofing is a property, that in security, that it's really important for many different applications. And having a platform that has the decentralized nature and tamper-proofing, to me, is extremely interesting. Now I'm done, so please.
No, I just wanted to point out one thing. You absolutely are right, but we need to be very clear. Finality is very important. Not all blockchains are equivalent. So if there is no finality, we have a slight problem. And this is why I normally point this out to everybody. Everybody makes a bunch of assumptions, but generally speaking, not all blockchains are equivalent for all the characteristics. The consensus protocols kind of dictates finality. If you don't have finality, so you can have a 51% attack and your graph is no longer valid. So some properties that we have in TPMs we can't have in blockchains, because in TPMs we can have finality, but in a blockchain we can't. So sometimes other mechanisms we know blockchain.
Depending on the blockchain, right?
Yeah, absolutely, yes, absolutely, yes. Yeah.
I mean, one other aspect of that I think is, and I think it will become more important as we scale up these applications, is fair ordering, right? So the ability to not front run transactions, to not insert transactions into the chain, and therefore, insert vulnerabilities that we haven't even thought of yet.
Well, one of the key elements that I think, Zenobia, you're talking about is that, look, if we take a system that is broken or has a huge amount of flaws, if you apply blockchain on it, which will have probably the same amount of fundamental flaws underneath that the system that you're replacing, but it makes a lot of other things better, then that's positive, right? I think sometimes, and this is the thing, right? There's some applications that a little bug is critical. Yes, on crypto, some vulnerabilities are insanely bad, right? Because of the implications. But if you look at the use case that Chenxi was talking about, or that where we can add value in a transaction, we can add value in the chain of custody, we can add value in a way that now you can have independent verification of a state of affairs, and then we have a way, going back to Jim's point, why can I have a way to share some of the properties of my security using a particular set of blockchain, which may be tied to a particular set of standards that can be then verified in different ways. But we now have a way to communicate, and we have a way to reach a consensus of in a way who's touching the system in a particular place. And especially, look, I'm now very getting into healthcare data, right? So and I'm very conscious that I don't want to own a lot of this data, right? I remember that one of the conversation I had with senior people was like, I think the idea of harvesting as much data as you can from people is the wrong one. You need to be a broker, and you need to be able to get access to it, or need to be able to give an access to when you need it. And I think blockchain can make a big part of it, because it allows certain types of information to be, and even custody, right? Like, for example, like there's a medical analysis, like, but if I can verify this integrity, and I think integrity of data is super important, because we in security sometimes we talk about confidentiality, availability, but in medical data, integrity is almost one of the most important properties. And who the hell was involved in the creation of that analysis, right? So having integrity of chain, all of it, and I actually like the idea that sometimes part of the chain we say, I don't trust it very much. I actually know that this part was built with great security. Then it jumped into these players, which we don't really trust, but then jumped to these other players that we trust. Well, guess what? It's a chain, right? Not by definition, probably not every single part of the chain has the same robustness. But if you understand it, right, and you can make assumptions and you can make risk-based decisions between a chain that 90% is flawed versus another chain that actually only 10% is flawed, and we had no problems in the past, and we can detect very easily if something happens on that chain. So actually, I'm comfortable with that one.
So, Dinis, there's something that makes me something that makes me slightly uncomfortable, and it's not got anything to do with what you just said there is right. So if blockchain is a more secure way of doing this, improving repudiation, integrity of data, that's great. But the problem I have is, and the worry I'd have is that there would be a wider societal issue where, and a good example of this was chip and pin. So in the old days, when we used to have to sign a card, right, people used to lose money all the time, and the banks just admitted they knew that this was a completely rubbish process with debit cards, just firing a number over, and they would, if a claim come in for a wrong thing, they'd say, okay, yeah, we get it, we know. So they would help that. Suddenly, when chip and pin came along, it was sold as, this is so secure, you cannot make a mistake. If you've used your PIN, it is secure. And for a while, for a few years, I mean, we all know it's 4 digits, right? It's just rubbish, right? So it's like, it's just like, the encryption is at accent level. But for a while there, whilst that was, the banks truly believe, or the people, the legal departments in banks truly believe that this was infallible, that actually, loads of people lost lots of money where, there was card skimmers, people didn't realize. And my worry is that if we present this as better security, what society hears is this is guaranteed, because this is what people want to hear for trust. They want to hear guarantees. Guarantees and trust are very, very, they lock together. So obviously once those vulnerabilities, magic vulnerabilities, do come through at some point and we fix them, we need to make sure that we're giving the correct message to say this is not infallible, right? Well, this is better, but it's not. There are some risks for this, which will dent the trust. So there's a really weird balance there.
Well, I think to start off, we've done a bang up job of the crypto industry creating some skepticism about its trust. Right?
Yeah.
People are, I think, inherently more skeptical of DLT because of what they've seen happen in the early days, right? But I think you probably saw that with every new technology, right? So in the early days, it is almost the vice applications that sort of lead the way because they have to, and then you build from there. But I think that's a really good point, James, that we can always do better, but we're never going to get to perfect in any security model.
Yeah, I agree. The one example I want to talk about is so I've been looking at this, so it's on top of my mind, is software supply chain attestation, for instance, right? So that's something that the US government is mandating now, and lots of large software providers are looking at to do. But this is a perfect example for blockchain because you're producing software and you may be producing attestation, but you don't know who's going to be the downstream consumer of your software. You don't know who's going to be using this validation. So it's a pretty good producer and many consumer model, and many different parties on the consuming chain would need to validate the information that you put together. So that was one of the things that we've been looking at as a possible application of blockchain. I think it's, there are many others, but that in itself, I think it's pretty valuable.
Yeah. And look, if blockchain's main contribution is the whole conversation, can you prove it? And here's a way to prove it. That's massive, right? Because at the moment, in most cases, we have zero proof. It's just, I think even Anish was mentioning, sometimes is the thing that is actually compiled is even what's supposed to be compiled, right? So yeah, I like the idea of moving to the world where we have to prove the chain of custody. We have to have a direct, in a way, the software bill of materials, right? Like we have that with food, right? We should have that with software all the way down to code. And to be honest, like what that will do is that will start to promote the right behaviors. That will start to promote a very, very healthy set of behaviors that on an industry, and we will make a much better economic model for the groups and the open source groups or the commercial companies or the commercial companies on top of the source, whatever, but to produce verifiable and secure software.
So I was about to say two things. Firstly, the bank thing. So when we had a chip and pin, Ross Anderson's group actually did an attack and they recovered the pin straight up. So the implementation was completely broken. Even though that was proven, the banks always push to the customer, right? Like, oh, you lost the chip and pin. It's your responsibility. And going back to security implementation in blockchain, Yehuda Lindell actually gave a talk in a Science of Blockchain conference, something titled along the lines of, design of, pragmatic security protocols or something. He clearly indicated the difference between academics and practitioners. That sometimes these two things merge, and one party doesn't understand what other party is saying, and the result comes out of the other end. And other people only find out, there's a massive bug in there, and it's still open in the blockchain space. Is open, and in the normal traditional banking, retail, whatever environment, we have a far more, what I would describe as a regulated mechanism by which, again, say PCI or whatever you could think of, that there are processes put in place. In a normal blockchain, where we still haven't reached a level of maturity where we could actually say, you know what, I got this piece of software. I know this cryptographic mechanism was implemented. This is how it's implemented, and this is the process it went through.
Yeah. And look, security has a lot of value, right? I think if you look at the way we look at security, the way that some of the process we know how to build secure software, the way how we need to build CI pipelines, I think we can bring a lot of value to those workflows, right? Fundamentally, this needs to be embedded in the CI pipelines, needs to be embedded in the way we build software, in the way that we share and push this. But of course, remember the elephant in the room is that we still build software in a very insane way, right? So, and also most organizations don't understand how they operate. So, there is a challenge here, which I still think that it's an area that should have a lot more investment, which is just how do companies operate, how the software is developed, how things are actually built, what's actually in there. Because the toolkits and the way the model works is still a problem. But I think blockchain, and I would say, I think the insurance business is going to push a lot of this to the right direction. So I'm a big fan of insurance companies because I think not yet, but I think they can play a big part of the solution because they can allow a certain risk conversation to occur, right? And once you get a much more mature insurance model and insurance companies that can give you micro insurances and it can give you small subsets of insurance, you can then almost use that to make a decision. And then, and that's actually a good driver, for example, for the adopter of blockchain, because you can say, hey, I got all these challenges. The insurance of that is going to go to the roof, or the cost of that and the risk go to the roof. If I apply this bit of technology, then the cost comes down, right? And I think that can add a lot of value.
Yeah, I was about to say something. It's kind of interesting. Am I on mute? No. So the thing is, like, the total amount of insurance possible in the blockchain space, say take Ethereum, is so tiny. So Opin is the largest insurance protocol. We have a few trillions out there, and you have 300 million. So I think we are looking at it into the distance. I completely agree with you, because like insurance probably is going to be the best mechanism to self-enforce people to do the right thing, because the insurance premium will be absolutely yes, right? Yeah. But unfortunately, I don't see. I mean, everywhere else, normally the insurance and reinsurance market is, at least an order of magnitude bigger than the market. But this is a reverse in blockchain.
Yeah, cool. Look, we have a couple more minutes left, so maybe some final words, or then we'll go around the room again. Zenobia, some final words and thoughts about, we ran around a couple of circles here, but clearly a very important topic to
Yes, yeah. Well, thank you for having us. I think we, when you're in it, and you've been working in this industry for a while, there is sort of this sense of urgency, and that, these are huge problems that we have to go and tackle. I think we do have to remember that we're so early in what this, this next phase of web and interconnectedness will look like, right? If you started in, 96 or 98 and said, great, the thing that we will use the internet for is to hail taxis. People would have said, that doesn't make any sense. You're crazy. Why would you do that? But all of that back-end infrastructure had to be built and had to progress and mature to the point where you could get the infrastructure for Uber and Lyft and all of those companies, and that engagement, so it's so seamless. So, there's a lot of work going on in the back end to make those things happen. And I think we will see iterations of, what this looks like, hopefully well beyond what we've imagined today.
Cool. Chenxi?
I would agree, and I think the panel is interesting because you see the different spectrum, the views on the different views on the spectrum. You got the pessimist view, you got the optimist view, and I'm always the optimist in technology innovation, although I'm a security person. But I think in terms of innovation, we have to look at from the business perspective, even though security can often be the gatekeeper or blocker, but the business benefits of innovations are there, and that will push the pace of implementation rather than security. So even though we have to keep security in mind, the promise and the business value that these new innovation delivers is what's going to drive the society. So that's my last word.
Cool. James?
I think it was a really good discussion. Some of it went over my head. But I'm definitely interested in some of these real world applications as to, again, like sharing data that doesn't really need to be shared. It'd be good to see it as a verification mechanism that something's actually taken place, as opposed to just containing that data. So I'm quite excited, sadly, for those types of applications.
Anish?
Yeah, I mean, thank you for having me. And obviously, you have my cynicism. So happy to be the cynical pessimist on the spectrum and having contributed to all the different things, in that sense. I am skeptical in my worldview. Philosophically, I've explained this. I think there's an information arbitrage that existed from prehistory, and it exists even now. The Googles, the Amazons, the Twitters of the world actually do it now. Prehistorically, the shamans of the world did that. The mechanism is the same. Somebody has information arbitrage, and if the information arbitrage is placed against the average citizen, they are at a disadvantage. I am hopeful that a blockchain and other mechanisms will try, get it to a stable state where we all have a fair chance.
Cool. All right, thanks everybody for participating. And look, this is the beauty of the summit, right? The summit is about these intersection of ideas. We usually, in the past, we've done this where we put everybody 5 days in one place and we all kind of have all sorts of ideas and swap, and we then intersect the people from threat modeling to security to blockchain to governance, and everybody kind of collaborates. So thanks for your time, and let's do a couple more sessions in the summit, and maybe let's pick some very specific topics so we kind of, focus a little bit the conversation. But this was really useful, and I learned quite a couple new things. So thanks everybody.
Thanks so much.